Kia ora Year 12 and Year 13. This is an A-level question, but I think it's also quite a good one for people doing scholarship calculus. It's a trig integration question, and it's a substitution question. So this is it here. So it's from an old A-level paper back in 2005. And we have to first of all show that this integral is equal to this integral, and we're told to use the following substitution. And then we have to find the exact value of a definite integral using that. But the thing that makes this question kind of tricky and not scholarshipy, but a little bit of insight is needed, is that when you look at how to integrate this here, you have to pause and think about which trig identity might help you, right? Because this is not a backwards chain rule integral. So I want you to pause the video here and just think about how you can integrate sine squared of theta. And I'll come back to that later on. Okay, so let's get into the question. So what do we want to do? Well, we've got this integral, square root of x over 1 minus x dx. You can see from looking that it's pretty gross. You've got a fractional power of a thing down here. The derivative of this is -1, and you've still got an x sitting up here. So this is definitely one where we're going to have to use one of our funkier methods to solve it. And we're told to use this substitution. So everywhere we've got an x, we're going to change it into something with a theta. I'll start off by working out the bottom line. So the top line is going to get replaced with that. 1 minus x is 1 minus sine squared theta, and we can see straight away that that's equal to cos squared theta. So just working that through before we put it back into the integral, we get x over 1 minus x is equal to the square root of sine squared theta over cos squared theta, which is sine theta over cos theta. So the last thing that I have to do, so let's square box that, is I have to work out this dx. So we're given x is equal to sine squared theta, and we're going to differentiate that with respect to theta. Because we don't want to rearrange it and make theta the subject, that's going to be messy. So dx by d theta will be 2 sine theta cos theta. So that's the last of our building blocks. Now we're ready to substitute everything back in to the original integral. To show that question, so don't leave anything out. So here we've got, and we've already done this bit, but never mind. So this and dx is equal to 2 sine theta cos theta. So that gives me sine theta times cos theta times 2 sine theta cos theta, and I've lost my d theta there. There we are, d theta, which gives us the integral of 2 sine squared theta d theta as required. Now the next thing we have to do is to integrate this. So the only extra stuff we've got left to deal with are the limits of integration. So let's do a table. Here's x. Now, what's theta? Well, we've got x is equal to sine squared theta. So the square root of x is equal to sine theta. Now I'm being a little bit loose here. I'm just going to hand wave to keep this video a little bit short. I'm not going to put that plus and minus in. Right, I really should do that. But where does that get me to? Well, theta is equal to sine inverse of root x. Now that looks bad, but it's not, because look at the limits we've got. We've got a quarter and we've got 0. So theta is equal to the angle whose sine is the square root of a quarter is 1/2. Right, and we know that that is pi on 6. And this one is the inverse sine of square root of 0, which is 0. Right, if you're not good with that pi on 6, it's time that you were looking at your special triangles. So there you go, there's that one. So this is my starting point. I'm now going to do the substitution and switch it all over. Right, so if you've been looking at this, hopefully you've thought about your angles, and you can see that somehow we're going to want to use the double angle cosine formula on this. So cos of 2 theta is equal to 1 minus 2 sine squared theta. You can work with it outside of the integral sign. It's probably the cleanest way to go here. So we get cos of 2 theta minus 1 is equal to negative 2 sine squared theta, or 1 minus cos of 2 theta is equal to 2 sine squared theta. I think that's the best way to do this. There's less chance of mucking it up than if you try and do your manipulation inside here. But over to you. Some of you will do that the other way around. So in here, suddenly we've got a much easier integral to deal with, or integrand, which is this. So that gives me theta minus 1/2 sine of 2 theta. Right, if you're in this year's A-level class and you're still making small mistakes with your trig integrals, you need to be doing some pretty urgent work out of either the Delta book or from Dr. Frost to make sure that you do lots and lots of practice at those. So please email me if that's you and you want me to set you some work on those. Now we haven't quite finished. We're asked for exact values. So this is going to be pi on 6 minus 1/2 sine of pi on 3 minus 0 minus 0, because sine of 0 is just 0. So that gives me pi on 6 minus 1/2 times root 3 on 2, which gives me pi on 6 minus root 3 on 4. So there we are, we're done. Thanks for watching. Make sure that you are really comfortable with all of the steps in there. I think last year's A-level exam in November had a pretty similar trig integration in it with, I think it might have been a cos squared or a cos cubed. Alright, let me know if there are any more questions that you want done.